1 through 8 on your desk? Yeah? 1 through 8 on your desk? 1 through 8 were the lecture problems you were responsible for finishing for yesterday. And I want that, I'm going to swoop around and just check for it to be done. You all have the answers. Were there questions that I need to go over on that first? Which one? Number 8, that was the barium chloride one. Barium chloride. Also, not started video. I have started. Okay. Oh, what is wrong with this? Okay. This one. I will review number 8 first. Right now? Right now? Okay. These things are everywhere. So guys, tell me where you started on number 8. Started 0.75 moles. What is barium chloride? The formula for it? BaCl2, right? Barium is a 2+ charge, chlorine is 1- charge, crisscross. You gotta write down your charges so that you can crisscross them. If you can crisscross them in your head now, totally fine, but if you can't, then write them down till you're good. So then the next thing you have to do is cancel moles. So you put moles on the bottom. So 1 mole of barium chloride weighs what? Those of you who got it? 207.9 grams of barium chloride. And that's what the question asked for. It asked for grams. So 0.75 times 207 is like 151 something. 0.925. 925 grams, but that has to be rounded down to 2 sig figs. So whenever you round, you want to round it to 2 sig figs. You have to look at the first 2 digits, but you cannot write 15, because 15 is very different than 155. You're not totally changing the number, so what do you round it to? Okay, you could do scientific notation, or you could just drop the 5 and make it a 0. Right? But the 5 does round that other 5 up. So instead of just dropping it to 150, it needs to be rounded up to 160. 160 grams is the best answer. Or, no, regardless, if you'd written it as scientific notation, it would still be this. 10 to the second. 1.6 times 10 to the second grams. Okay, so you have your test on your desk. I know we're going to go over that shortly. But my people who are going to be leaving me, the unit test review, the multiple choice review, I do want you to come back for that. If you can till tomorrow or maybe next week sometime, just because I want to make sure that you're good with your nomenclature, because it is going to haunt you forever. Okay, it's going to haunt you in your dreams. And then the multiple choice lab is fun. You're going to miss it. You don't have to make that part up. The competition notes, I'm going to be videoing that. But the simulation is also very simple, and I'll be videoing some of that. So you're really responsible for this lower part here, specifically 2. Okay, any more from 1 through 8? Just on your desk for me right now. Yeah. And you guys start these for me. I want you to try these first before you go over test. Try these first. And those of you who are leaving, they'll make an announcement. You'll have to. I'm looking for 1 through 8, though. Looking for 1 through 8. Okay. What are we supposed to be doing right now? Okay, I'm going to start giving out the 10. Try not to do that in honors because you don't need it, but you don't know how to play school with me. can at least try to start them. You can start.
Sorry, guys, like that.
Teachers, please dismiss students with the last names that begin with A through L to sign up for the PSAT. Report to the cafeteria at this time. Again, students with last name beginning with A through L, report to the cafeteria at this time for the PSAT.
Alright, for those of you who are leaving, you do need to take your stuff with you. And the video will be up later. I got you. I'm checking for completion. Anybody who signed up for the PSAT, A through L, will be ready to If you take the Scantron, don't take them on the free. The Scantron, I want you to hold on to. Alright, 5 people.
Students, please bring your things with you when you report to the cafeteria for that PSAT. Thank you.
Okay, so I just checked to make sure everybody had their stuff. I appreciate it. This will be an easier day because you know what the heck you're talking about, people. Alright, if you guys feel neglected, look at these empty spots up here. You can scooch over here. Yeah, that was not a suggestion. Okay, so tell me what we have here so far. Scooch over here so I can see your faces better. Pretty faces better. Lizzie needs a buddy. Emma needs a buddy. Jacob needs a buddy. Look at these people need buddies. Okay, so tell me where you guys started on number 1. Tell me.
I started at the 100 grams, but
100 grams of what?
potassium chlorate.
I can't believe I gave that to you. Shame on me. Potassium chlorate. Okay. If you know that you're in grams and you have to go someplace else, what's going to be your stepping stone pretty much always? Moles, okay? But that's grams of oxygen, right? So there's 2 ways to do this, and I'm going to tell you the first way that you understand, and then I'll tell you the other way a little bit later. But I want you to go ahead and get some moles of this substance, this potassium chlorate, and then we're going to go to just simply moles of oxygen through the internal mole ratio, and then 2 grams of oxygen through molar mass. So first thing first, I want you to cancel out grams. So where do I put it? On the bottom. What's the molar mass of potassium chlorate? Who's already got that? Anybody? What's potassium's mass?
39.
39.1 plus chlorine's mass. Looking at the periodic table. 35.45 plus 3 oxygens, each weighing 16. So what's the molar mass? 122.55. I got you guys. But I'm going to start giving like a participation credit in class or something. Like the top 5 people who participate the most get extra credit. Because some people just sit and watch. And it's like the most boring thing ever. You've got to participate, like calculate some things. Okay, so I'm canceling out grams here. But what is that equivalent to? 1 mole, because that's the molar mass conversion of potassium chlorate. So write KClO3 because it is important to know that we're talking about KClO3 there. Alright, so now we don't care about KClO3 anymore. We care about just straight up oxygen. So this is where that internal mole ratio thing came in. So inside of potassium chlorate, how many oxygens are there? 3. So it's a ratio of 3 moles, or 3 times as many oxygens, because of that subscript of 3 there, per just 1 potassium chlorate. So we just do that because we need to isolate the O by itself. And I told you guys this internal ratio thing yesterday, because it's easier to do it this way than like a 5-step process, maybe more than 5, 6-step process. So our KClO3 grams cancel, cancel, moles of KClO3 cancel, cancel. We're in moles of oxygen. What's our last step? Right, what is our grams of oxygen? Yes, you're just simply looking at the periodic table. So 1 mole of oxygen is 16 grams of oxygen. And then tell me exactly what you're putting in your calculator so we know what we're doing.
100.
Divided, doing what? Sorry, 100.
100 divided by 122.85.
Uh-huh.
Times 3.
Times 3.
Times 16.
Okay, and that is?
39.1.
I got, oh, I divide by the, yeah, so 30, tell me what you got again? 167 grams of oxygen, and what would that round to?
39.6.
So yeah, 3 sig figs, that should be 16.0 because that's from PR table. So 3 sig figs would be 2 grams. Between 2 and 3, tell me which one I need to do right now. So how much iron, that's basically the same style of question, so either one works. So how much iron can be recovered from 25 grams of, what is that's name? No, do not say dye. It is a metal. You start with saying the name. Go. Iron 3 oxide, because the 3 belongs to iron from crisscrossing. Okay, so tell me, what are you starting with? The only number there, right? So 25 grams of iron 3 oxide. I can't do anything with grams, right? But this question is actually saying how much iron. That means how many grams of iron. That's the real question. Much means mass. Okay, so what do you guys want to do? We got to take it in moles. That's our favorite stepping stone. So I'm going to put 1 mole of iron 3 oxide on top. Tell me how to add it up. So iron raised, so I'm doing 2 times 55.85 plus 3 times 16. Okay, so 159. See, and you can just do that in your calculator. You do not have to show me out how you calculate molar mass. I know it's adding, but if you make a mistake, then it will mess up your problem. So just be very careful. Okay, so now I'm in moles of iron 3 oxide. I need to get just only iron, and then I can go to mass. Okay, so how do I do only iron? Okay, what's that internal ratio? All right, because there's 2 to what? 2 to 1. You're always, okay, so I'm going to write that down first. So 1 mole of iron 3 oxide is on bottom, and so then from here you're like, okay, how many irons are in one of these? Just 2 of them. So you always have it per 1 mole of the whole shebang, and then you go 2 moles of iron are in it. So then what do you do from here? Because we're still not to grams. Right, so if 1 mole of iron goes on bottom, because we need to cancel out moles and moles here. Sorry, I've not been canceling, there's moles there. And then what goes on top for iron? 55.85. Again, 55.85, because that's the mass found on the periodic table. So we did a good job. We canceled out our grams of iron 3 oxide, our moles of iron 3 oxide, our moles of iron, and now we're in grams of iron. So, yeah.
Thank you for pictures.
Yeah. So we just need to calculate now. So you guys calculate that. Yeah. BB. I go AB. I'm starting to learn my schedule now. AM 160 on Friday. So tell me what you guys got for your iron. 8.4? 4.8? 4.8. Sorry, okay. Grams of iron, and that would be rounded to how many seconds? 17.5. These are awesome. Look at this. Stoichiometry. You can say you're stoichiometry beast now, okay? Yeah.
Stoichiometry and
Dimensional analysis. Basically the same thing. Dimensional analysis is just like, doesn't necessarily have to deal with chemistry. Like I could say, okay, I've got 40 horses. There's 4 for worse. I could be like in a general example, but stoichiometry is like chemistry, dimensional analysis. Okay, so I'm not going to do the last one right now. Let's go outside. Yeah? Okay, hold up. I got to tell you what you're doing outside first. So I'll go over some of the stuff. Just your piece of chalk, which I'm going to get you in a second, okay? So this is called the Moles of Chalk Lab. You have to write good things about chemistry in chalk outside. I love my lab partner. We're bonding. You know, I'm all about that. Or AU. AU. What's AU?
Gold.
AU, right? Oh my gosh. I read some of them, okay? So we are only going to go outside for a short period of time, but what we have to do first is we have to mask our chalk, which is calcium carbonate. I'm not going to tell you what that is. You know what this is. And then we're going to go outside, make some cool stuff happen, and then come back in, mask our chalk, figure out how much calcium carbonate we use to write all of our lovely things. Okay? There's scales, there's chalk. I'll see you in 1 minute. Go get this thing started. Okay? This is going to be on the lab stations too when we come back.
Courtney told me you're just studying too.
Hey, JB.
I could expect that, Jay, but I'm like, this is so hard. You can do it with a partner. Oh, there's chalk around the lab stations already. There's chalk around the lab stations too.
Oh, let's
Chalk
do it.
around the lab stations too. Oh, you can share or you can each share. Okay. After you mask, write it on the lab station chalk.
It wasn't me.
It was him. I thought it was.
There's an extra seal there. Why don't you
Oh, I don't know, because that's on my face.
Oh, well.
I was doing.
write that right here? Write it down on the lab station when you get done with your masses.
28.44. 28.84.
Well, this, right?
Not. That's not right. Let's see this one. Yeah, these aren't gonna show up.
Well, it showed up there, Jack.
All right, we're going outside in 30 seconds. Did everybody have their mask?
Wait up, chalk after right.
Yeah, we gotta take which one.
Well, no, wait, somebody get down that
You're not like you're the most
No. Like, alright. Do we share their sheet? That's what I'm saying. Get that so perfect, man.
Okay, and we're going outside in 5, 4, 3, 2, 1, go. Beep.
Wait, do we need to write on that paper?
No, do not write on the paper. The paper is my lab sheet. Do not write on paper. That's why I said write it on the lab station. That's all. And go outside. And I'll call each other. Be good. Be good.
I'll be back.
They show you it. They turn the monitor on. I show it to you again. They show you the screen.
Oh, man,
Not
I
everybody.
Yes, and then your nail scratches. Oh, that hurts so bad. Ah, all right.
The instructions are on the lab sheet in front of you. You have 10 minutes or less to get that done. Okay?
Is there an element that has a Q in the left?
You have 10 minutes or less. I would say like 8 minutes actually. 8 minutes. Let's do this.
I've come to get paper to write my answer.
Yes, now for sure you need paper. Now for sure you need paper. Oh, that calcium carbonate. You guys, calcium carbonate are just little fish shells.
Ew.
Yeah.
Y'all know what me like. Okay. When y'all get stuff dirty, it's just the funniest process. It's the funniest thing.
What? I don't know what you're talking about, man.
When y'all get stuff dirty, like if y'all have like some nails and y'all mess up, take a chalk.
Oh my gosh, it's better here for you when I am. Actually, favorite.
You can have a single piece of paper. You can have a group piece of paper.
No, pen. Pen.
Let's put this way so that we can see it. You think B10? Mr. Makes it like, luckily this is good. That's a good chance to read.
No, it's supposed to. With a calculator.
This is the easiest one. We already got the
We'll surprise you tomorrow.
I got you. What is
Well, no, we have it in green.
yeah. How many balls? How many?
Kendall, work with Hydeja. Work with her like on the math part. You guys have your separate data, that's fine. Just so you have somebody to ask questions to.
So let's figure that out. Anybody got ideas? Finding the low mass of
Someone called.
yeah.
It's okay. I'm right on the table to show you that it'll be done. I will.
bunch of girls got
That's the mole in that. There's the mole. Point one. Point 011.
The whole amount. So there's a lot of that. There's a lot.
Atoms in salt. Alright, now we're in moles. So we gotta go from there to particles. Moles. We have a bunch of things. What is that? Particles, Alright, we need an actual calculator. Yeah.
That was already 6 minutes. Who's going to mold yet? Who's going to formula units? Okay, I wrote Adam for the formula. You have about 2 more minutes. That's it. It should not be hard.
Alright, so we need to get to chalk and then calcium. Alright, someone grab an actual calculator. Grab yours. What?
What?
You funny.
How does that sound?
Because you fight it.
How many oxygens are in this? Three. Oh no, I just got grams. You don't need grams. What? You need atoms. You know what you're gonna have?
Julia.
Alright, so instead of 16, we go to
That time.
It's fast.
That is fast.
Okay, I'm trying to give you guys more time. Just we still talk about percent composition today. Yeah.
You guys are confident? I'm about to go discuss it here. How many calciums are there? One. Why is it the exact same?
Which one is it?
Chalk and calcium.
What do you mean? What's the exact same? The atoms?
Calcium now is chalk, what it says. Oh, that's just grams. Yeah, that's what it has to be. Okay. I'm smart on that. Alright, find how many grams are in that. 40.07.
Alright guys, no, I don't know. Put it in the box. If not, hold it and you can use it later. Wait, put it in the box, you percent composite. If you're done, you can box it. Yeah, it is. I'll see you at your seat in less than a minute.
Grams.
It's okay, just wipe off your lab station, hold on to your paper until you're done, but thank you for some of you being efficient. You're like, no problem though. Alright, I'll see you up here. I'm counting down in my head from 30. Okie dokie. Are they tricky? So, we have about 35 minutes left in class. So, percent composition is our next little topic. It's not very hard. Look on your reading guide right now and tell me what percent composition's formula setup is. So, you wrote it down on question 7. Say it again. Grams of the element. Hold on. Over grams of compound, I believe, right? So grams of, I'm going to say grams total compound. And then do what? Times 100, because all percents require you to multiply by 100. And that gives you percent of the element, whatever the element of choice is here. So a percent, like for example, if I had to count up how many boys you have in here, 1, 2, 3, 4, 5, 6 out of, let's just say 12 for easy sake, okay? There's 6 boys, 12 total, what's the percent boys? 50%, right? Well, we can do that with mass in terms of composition of the compound too. We just have to look on the periodic table to tell what the mass is. So you should have your periodic table out. I think I'll do like 3 or 4 examples. I do believe that we will talk about Archimedes simulation if possible. We will see. Okay, so this, we just kind of just talked about that. That's our kind of go-to formula for now. It is right here. I'm going to use that to answer these 2 questions, and I believe I've actually printed this part for you. Maybe. Nope, sure didn't. Okay, so here we go. I want you to tell me the mass percent. Anytime we're doing percent, it's always mass percent. And I want you to tell me the mass percent of magnesium phosphate. So basically what that means is I want you to tell me the percent of each element. Okay, so before we do that, we probably should write down what magnesium phosphate is. What is that? Mg. I hear PO4, right? But where are the charges? No. Where's the 3? Behind the magnesium, because that's 3 was the crisscross down, and then the what for magnesium crosses over? 2. Okay, so there's magnesium phosphate. Wow, big compound, right? So I need to take these specific elements out, and then we're going to put the total on the bottom. So how many magnesiums are here? So the first one I'm doing is percent magnesium. How many magnesiums are here? 3 of them. 3 of them times the molar mass of magnesium. So I'm just going to put Mg there for now. Over everything else. That means including magnesiums. There's 3 magnesiums plus how many phosphoruses or phosphori? How many? How many P's? 2. This 2 applies and it multiplies by the imaginary 1 there, so that's 2 times 1. So there's 2 phosphoruses and how many oxygens? 8, because it's 2 times 4, so that's a multiple, that's multiplied, so that's 8 oxygens. So when we take that mass over the total mass, times it by 100, that's going to give us our mass percent of magnesium. So now we just got to math it up here, okay? So tell me the values. 3 times what's magnesium?
24.31.
24.31. I had a yellow calculator.
Do you have any more of those questions?
Here. My calculator. Okay, 24.31. And then over this one, I'll write out for us for this specific one, but I'm not going to write it out anymore because you guys can add this up. 24.31 for magnesium plus 2 times phosphorus, 30.97, plus 8 times 16 for oxygen. Okay, so all this is in the denominator, but that's a lot to write out every time. You do not need to write that out. You just need to simply add it up in your calculator and then write it down. So 3 times 24.31 is 72.93 grams of magnesium over all that mess together. Anybody got all that messed up?
262.8.
Is that what you got?
I mean, I'm dividing both of them.
You just got the answer. Okay, so 261.85.
262.8.
I'm guessing that's right. My answers are up there. So this is grams total, and then don't forget to times by 100. And Caroline, tell me what you got.
19,092.
Well, you can't have over 100% yield, right? Because I mean 100%. 100% is the max. So somebody else try. Do your mass over the mass total. There's probably just a parentheses that's misplaced someplace. That sounds better. 27 point what? 745. So let's go 24 or 74. We round up to and down 7. So 27% magnesium. All right, that looks like a lot of work, but I gave you the skeleton. We do not need to write out that much information anymore unless you feel like you need to. So tell me, how would you do the same thing for phosphorus? How would you get percent phosphorus? Tell me your kind of setup. Huh? 2 times what's phosphorus mass? 30.97 grams over, and I'm just going to put total because we got that total previously in our calculator someplace. So when you do that divided by your total times 100, how much do you get? takers? 23.6% is going around there. So I'm not going to do the same thing for oxygen. I'm just going to go easy route. How do I figure out percent oxygen? Minus from 100, right? So the total sample should be 100%. So 100% subtract these two added together. What is that, like 50? 51? No.
It's
50, 51.3. Yeah, so I just took these two and added them together, get 51.3. So 100 minus that gives me, oh, you were probably telling me the final, sorry. 48.7, gotcha. And that's percent oxygen. Okay, so if I wanted to do this again, but for a composition including a hydrate, that's what, I'm just going to do one example there, and I think you guys kind of get the point. But a hydrate has water embedded in it. So this next question, calculate the percent composition of water in the following compound: zinc nitrate tetrahydrate. We only talked about this like one or two other times, but this was our example of copper 2 sulfate pentahydrate. We dehydrated it in our very first lab. It was blue, and we dehydrated it, it went white. So this is a similar situation. Before we can start, though, you have to write down the formula. Go. I hear NO3. Hold on. What's zinc's charge? 2. Zinc is a 2. Oh, sorry, I heard 1. Zinc is a 2. And how do I remember it? A Z looks like a 2. Yeah? Okay. So zinc has a 2 charge. And I don't tell you it, even though it's a transition metal, because it always has that charge. It never fails. So the 2 goes down there. The nitrate has a 1 minus charge and crisscrosses over. This is where we had bullet point, not multiplication symbol, bullet point. How many waters? 4 waters. Okay, so that's the formula. Zinc nitrate tetrahydrate. Okay, so to get percent water, it's actually, I think, a little easier because we're only getting percent water. We don't have to do all that every single element thing. So how many waters are here? 4 waters. What is the mass of water? Add it up. You can probably do that in your head. 18.016. And that's because you took 16 for oxygen plus 1 plus 1, so 18, but there's a little bit left over, so it's 18.016. That's the 4 waters over the whole shebang. So in your calculator, let's add this up. What does zinc weigh?
65.38.
65.38? 39. Plus how many nitrogens? 2 nitrogens, so plus 2
14.6.
times 14. Plus how many oxygens? 6 of them, so plus 6 times 16. Plus how many waters? Because water is still included in the total. So 4 times 18.016. Alright, so you have your total mass of what? 261.45 grams total. Okay, don't forget percent to is multiplied by 100. Tell me that mass percent. Anybody, whenever you're ready. So I'm just going to round that up to 6 if that's okay. So that's our percent water. So then what's the percent zinc to nitrate or zinc nitrate? What's the percent zinc nitrate? 72. So the other half of this, right? The other part of this, 72.45, right? So that would be 72.45% zinc nitrate. Okay, there we go. Okay, so we have stoichiometry down. We've got percent composition, at least a couple of examples. Oh yeah, I think we will. I want to show you one more example, and then we'll go get we'll get Chromebooks in a second. Can I? Okay, scroll down. That says 72.45. Okay, so this is on your chart, but I don't think we need to do that because I think you guys get how to do this. Do you guys need more practice on the elemental part, like pulling the elements out, getting over the total? Okay, and then This right here is the pre-lab to the actual lab, the simulation. The simulation is very, very easy. It's pretty short. Let's maybe like work through the first couple of these, and then I'll let you guys go to the computers, okay? So write this on a separate sheet of paper. This is the lab. This is simulation lab, okay? So calculate the percent silver in silver sulfide. And then I want to use that to calculate the mass of silver in 10 grams of silver sulfide. So I'm going to write the you guys tell me how to set up or you guys try with a partner on 1 and 2 and tell me what we need help on. There should be examples right in front of you that are helpful.
Silver has a decent one. If you guys have missing work, then you need to get stuff in because grades are due in the like 3rd week of October. All right, so tell me how you guys got number 1. Calculate percent of silver and silver sulfide.
Oh, you want
Tell me how you did it. Come on, let people kind of come back to your seat. Tell me how you set up number 1. So 2 times what mass? 107.8 grams of silver over, what was the total? 247.87 grams total times 100, and you got for what for silver? 87.66. I was going to hold that decimal out a little bit there because I want to use it in my next one, okay? So too much rounding error will cause error. So did everybody feel comfortable doing that part? You take your element, you multiply, divide by the total. Now number 2, I'm going to show you how to use mass percent that you just got and apply that in number 2. Because a percent is going to be the same percent no matter how many grams of that substance you have. So if I had 1,000,000 grams of silver sulfide, still only 87.66% would literally make up the silver's amount. So if I have 10 grams of that, how do I figure out how much silver I have in the 10 grams?
You multiply it by 0.876.
Good. So you know how to use percent. It's the same way you use percents in any other way. It's 0.8766, which is the percent as a decimal, and you multiply it by the mass of 10 grams of silver sulfide, and that isolates just the amount that silver makes up, which is just 8.766 grams of silver. So you can use percents by just multiplying to get from a total mass, the amount that silver in this case makes up. Okay, and let's briefly just talk about 3 here. 3, we have, it says it right there, darn it. Barium hydroxide octahydrate. If I said something was a hydrate, what does that tell you the formula has in it? Water. And if I say it's an anhydrate, or anhydrous, what does the prefix an mean? Not or without, right? Okay, so what do you think it doesn't have? No water, right? So that would just be barium hydroxide without the whole water deal in the end there, okay? So anhydrous just means without water. So like in our example, it's like the blue crystals have water embedded in the crystal, the white crystals had it dehydrated out, so there's no water remaining. So I think we could do this, and we can do that now, so I'm not going to do those. All right, so if you have the computers pulled up, you'll go to my website. You guys will get, I think you guys will get this done. It's pretty fast. Go to my website under Unit 3 documents. I'm sorry, Unit 4 documents. We're in Unit 4 now. It's the first thing listed, and there's a little simulation, and it requires you to let some copper 2 sulfate hydrate, ask for you to heat it up, allow for the water to evaporate, and then your job is to figure out the mass percent of water in that substance. It's pretty simple, but the lab itself takes about 2 days, and we didn't have that kind of time. Plus, other people were going to be gone, so this was our best option. So going under here, it's called percent composition simulation. It looks like this. I'll leave this here if you guys want to read anything, but in just a second, when you scroll down, there's a link for the simulation, and it tells you kind of initially what you should be looking for. But here is the data table that you can, if you want to now, kind of set up. It doesn't have to be this beautiful, but you'll have mass starting, mass starting and mass final. That's the first thing you're going to be able to get. And then from there, we can convert. So try your best on that, and ask me questions as you go. Is it pulling up for you? Yeah? Go to my website. I'll leave that there so you can read it for a second if you need to. I put you guys in partners, but if you want your own laptop, grab your own laptop. Or get on desktop. Wi-Fi, guys. Amazing. Just go ahead and start. Yeah, outside.